Good day to you. With this presentation, we will begin a series of sharing on the geology of Morocco. You should know that Morocco has an incredible wealth of geological sites that have greatly favored the advancement of geosciences in the Mediterranean basin, and even globally. So, come with me on this fascinating journey that will last only a few million years. In a future series, we can focus on the 3.5 billion years recorded in the land of Morocco. The geological landscape of Morocco. General structure. Morocco reveals a geological complexity shaped by millions of years. To the north, the Rif is a young range, a result of the Alpine convergence. The center is dominated by the Atlas, high and middle, formed by the inversion of rifts due to this same alpine orogeny. These chains generally run from SW to NE. To the south, the anti-Atlas exposes much older Proterozoic rocks, testifying to its membership in the West African Craton. Between these massifs, the Moroccan Meseta forms an important structural domain. This richness is crucial, as it links the geomorphology to mineral resources. The map is a true chronology of events, from rifts to uplifts. Good day to you! We continue our journey into Moroccan geology to focus on one of the most important elements of Morocco's geology, the formation of the High and Middle Atlas, and, essentially, that famous theory of rift inversion. The formation of the Atlas Mountains, the rift inversion. The formation of the Atlas mountain ranges is the spectacular result of the convergence between the African and Eurasian plates. During the Mesozoic, the Atlas first underwent an extensional phase linked to the opening of the Atlantic Ocean. This extension created deep rifts in the crust, where enormous quantities of sediments accumulated, often associated with volcanism. But starting from the Upper Cretaceous, the movement reversed, shifting to alpine compression. The ancient rift faults became reverse faults, a process called rift inversion. The compression folded and lifted the sediments accumulated, giving rise to the High and Middle Atlas massifs. To continue this journey in the land of Morocco, we're going to take a look at the ancient basement associated with the West African Craton. This is a fascinating geological topic. The anti-Atlas Mountains in Morocco are considered the exposed northern edge of the West African Craton, which is one of the oldest and most stable pieces of continental crust on Earth. The Anti-Atlas, the foundation of the African continent. The Anti-Atlas is the oldest domain in Morocco, exposing the very foundations of the African continent. Its base is a crystalline basement formed over 550 million years ago during the Pan-African orogeny. This basement is an integral part of the West African Craton, the stable core of the plate. This basement is covered by a thick series of relatively undeformed Lower Paleozoic sedimentary rocks. The Anti-Atlas is structured into inliers, boutonnières, where erosion has pierced the Paleozoic sedimentary cover to expose the older crystalline basement at the center. It is a veritable open-air laboratory, fundamental for the study of the Precambrian and historically rich in mineral deposits. Relief as a climate regulator in Morocco. Good day to you. We continue our Moroccan geology with another section, but this time it is a parenthesis I am opening to focus on relief as a climate regulator in Morocco. The heart of the Moroccan relief, the Atlas mountain range, acts as a fundamental climatic divide, separating the Atlantic influence from the arid interior domains. The mountains are oriented perpendicularly to the humid Atlantic airflows. The western slope receives abundant orographic rainfall, while the air, descending dry and warm on the eastern slope, creates an arid to desert climate. This is the rain-shadow effect. The Atlas is also the country's natural water tower. The accumulated snow and the rain it receives feed the main rivers, like the Oumerbia, ensuring the spread-out and regular flow crucial for agriculture. Oceanic influence and the coastal meseta. Good day to you. We continue with the parenthesis opened in the previous section, this time focusing on the importance of oceanic influence and the coastal meseta. The low, rolling reliefs of the Moroccan meseta stretch between the Rif and the Atlas, forming the hinterland of the Atlantic coastal plains. This coastal facade exerts a moderating and humidifying influence. The ocean, thanks to its thermal capacity, acts as a temperature regulator. Coastal regions experience mild winters and temperate summers, typical of the attenuated oceanic climate. Furthermore, the cold Canary Current to the south causes persistent mist and fog. This phenomenon creates atmospheric humidity that moderates coastal dryness and supports the intensive agriculture of the Atlantic plains. The active frontier, tectonic collision. Good day to you. We are continuing our geological journey through Morocco with another section that focuses on the active frontier, represented by the collision between the African and Eurasian tectonic plates. In this regard, we can say that Morocco is a true window into this collision, which is still ongoing today between Africa and Europe and has been for millions of years. Observe the Strait of Gibraltar. It is a critical meeting point. The Rif Mountains to the south and the Betic Chains in Spain to the north are the result of a complex tectonic process of subduction and collision. The driving force is the constant northward movement of the African plate. This thrust has uplifted the Rif and the Atlas, and it is responsible for the region's seismic intensity. Morocco is not a simple boundary, but an active frontier, where the legacy of the Atlantic rifts is superimposed on the compressive effects of the Mediterranean. Phosphates, the great sedimentary treasure. Good day to you. We continue our Moroccan geological journey with another section focusing on a wealth that characterizes Morocco: phosphates, the great sedimentary treasure. Morocco's phosphate deposits are the most important in the world, representing more than 70% of global reserves. These deposits are not volcanic, but sedimentary and biogenic. They formed in shallow, warm epicontinental seas during the Upper Cretaceous and Paleogene periods. The key element was upwelling. This phenomenon brings deep, cold, nutrient-rich marine currents, dissolved phosphate, to the surface. The intense biological production that resulted led to the precipitation of phosphate and the formation of nodules and grains on the seabed. The main basins are located in the meseta, notably in Kurigba. Mineral and water resources. Good day to you. We continue our journey into the fascinating world of Morocco's geology, and this time with other riches from its rich and fertile subsoil, mineral and water resources. Morocco's geological wealth is intrinsically linked to its resources. The presence of ancient rocks, Proterozoic and Paleozoic, in the Anti-Atlas is at the origin of a varied metallogenesis. It notably includes copper and cobalt, often associated with the ancient volcanic structures of the basement. Geology is also vital for water. The Atlas massifs play a crucial role as water towers. Folded sedimentary rocks form important confined aquifers, which are recharged by snow and rain. These surface and groundwater reserves are vital for agriculture and cities. Geological history of Morocco. 4 key stages. Good day to you. We continue our Moroccan geological journey and take a short break to provide a brief summary of the geological history of Morocco. 4 key stages can be defined. The geological history of Morocco is summarized in 4 major phases. 1. The Precambrian, more than 540 million years ago, formed the Pan-African basement of the Anti-Atlas. 2. The Paleozoic, 400 to 300 million years ago, saw the formation of Pangaea and the Hercynian orogeny, whose roots formed the base of the Meseta. 3. The Mesozoic, 200 to 150 million years ago, is marked by the dismantling of Pangaea and the opening of the Atlantic, creating volcanic rifts and the future offshore sedimentary basins. 4. The Cenozoic, 80 million years to the present, is dominated by the Alpine collision, where compression reverses the rifts to form the High Atlas and Rif mountain ranges. Rotation of the Atlantic coastline. Good day to you. We continue our Moroccan geological journey with another section that will bring us back to the collision of tectonic plates that generates mountain chains. Before this collision, Morocco was further south, in an almost equatorial position with a coastline orientation that was west-southwest to east-northeast. The convergence movement of the African plate northward was accompanied by a shift to a more northerly position, but at the same time a rotation of the coastline that migrated toward the current direction, that is, a south to north direction. This rotation is due to the obstacle represented by the Asian continent to the east, which prevents any movement in that direction. So what is this rotation of the Atlantic coastline? The current configuration of Morocco is the result of the rotation and displacement of the African plate. During the Triassic, Morocco was joined to North America, situated at equatorial latitudes 0 to 15 degrees north-south. The opening of the Atlantic, progressing in a scissor mode, induced a slight counterclockwise rotation of the African plate. This rotation moved the Moroccan block toward its current position, in the subtropical zone. The initial stretching created the line of rifts that became the new coastline, oriented northeast-southwest, which we observe today. Evidence of past equatorial position. Good day to you. We continue our story of the coastline rotation, and this time with another section focusing on evidence of past equatorial position. The evidence for Morocco's ancient equatorial position is numerous. The most direct proof is paleomagnetism. Analysis of the inclination of fossil magnetization in the Triassic rift rocks shows a very low inclination, typical of rocks formed near the equator, 0 to 15 degrees latitude. Climatic indices confirm this. The massive deposits of evaporites, salts, and gypsum in the rift basins attest to a hot and arid climate. Similarly, the Triassic continental red beds, colored by iron oxidation, are typical of the tropical and desert paleolatitudes of Pangaea. impact of displacement on biomes. Good day to you. We continue with the influence of this coastline rotation, and this time with another section focusing on the impact of displacement on biomes. Morocco's displacement across latitudes has directly driven its succession of biomes. In the late Paleozoic, the equatorial position favored a hot and humid climate, conducive to forests and marshy areas. In the Mesozoic, the northward shift caused Morocco to cross the subtropical high-pressure belt. The dominant biomes then became hot, arid deserts characterized by the evaporites and the red beds. Today, stabilized at 30 to 35 degrees north, Morocco has developed a strong climatic zonation and the current biodiversity, dominated by the Mediterranean biome and cedar forests at high altitudes.